heard all the clues. Keep your chest up, push your knees out. You think you're doing everything right, but it just feels all wrong.
It might be because you're not using the right form for your body type. When it comes to lifting weights, there are two major factors to consider: balance and moments, both of which you learned about in high school physics class. Technically, you're balanced when your center of gravity, or most of your mass, a nice way to say it, is positioned above your base, or where you're connected to the ground. When it comes to the gym, the importance of this is fairly obvious. You're going to have a hard time making any progress if you topple over every time you pick up a weight.
Moments are a little less straightforward. Moments in physics have relatively little to do with time. Instead, they measure the turning force around a pivot.
The example of a teeter-totter works best. The more length one moment arm has over the other, the more mechanical advantage is produced. Hence, the little guy is able to lift the less fit individual in this illustration. Another way to think of this is with a crowbar. If a nail is in a board, we can pull on it with our hands and never move it. But with a crowbar, you won't need as much elbow grease. Just apply a bit of force to the end of the handle and voila, it comes loose. This is due to the moment. By using a crowbar, the force you exert is much further from both the nail and the pivot, also called a fulcrum, so there's a larger turning force, or moment, making things much easier.
When it comes to lifting weights, the goal is to minimize moments around all the relevant joints, keeping your center of gravity above you so you stay stable. After all, it's hard enough fighting gravity, let alone biomechanical inefficiencies. This is where individual anatomy comes into play. How you reduce moments around your joints depends on how long your limbs are, your relative muscle strength. For example, let's look at the squat. The squat recruits two main pivots, your hips and your knee joints. Two main levers, your femur and your torso. If you have long legs and a short torso, the challenges you face are going to be very, very different than someone with short legs and a long torso. To see why, let's look at some simple illustrations.
As you can see from the image, the person with long legs and short torso has to bend a lot more to keep their center of gravity above their base. Because of this, they have to fight against larger moments and need to work a lot harder to avoid tipping forward. On the other hand, the person with shorter femurs and longer torso will have an easier time staying upright, as the sections of their bodies don't move too far from their center of gravity. Let's compare two real body types. We'll call him Sean Long and Sean Stout. As you can see, Sean Long has a much more pronounced forward lean in order to keep his mass centered. So he either needs superhuman hip mobility, or he must lift a lower weight, or not squat as far. So Sean Stout has a definite mechanical advantage in weightlifting, although maybe not in basketball. How about another exercise example? Bench press, Sean Long and Sean Stout. Let's think crowbar. Look at the arms. If the upper arm is longer than the forearm, what do we have? Yep, a crowbar, a mechanical advantage. So again, Sean Stout has more mechanical advantage. Take another look. They are at the bottom of the bench press cycle. Note how deep each one's elbow drops. The further they drop from 90-degree angle, the less efficient the lift will be. Two things can cause this. One, really long upper arms, such as Sean Long. Or two, a lanky chest versus a barrel chest. Once again, Sean Stout has a mechanical advantage in not having to push the bar as far. One last example, bicep curls. Answer this question: whose arm looks more like a crowbar? That's right, Sean Stout has a shorter forearm and more closely represents the crowbar.
Okay, I think we have it down, but I'm feeling the need to throw a little math in. Don't worry, it'll be painless.
Basic math for mechanical advantage. Just remember that the arm and the moment are the same thing. You can see the length is relative to the weight equally. Okay, that's it. Enough math. You took your medicine. Like a champ, by the way.
Of course, there's other factors that affect form. First, there's the issue of injuries. If you're recovering from an injury or you have a sensitive area, your best option might be to alter your form to avoid aggravating that area. There's also the issue of mobility. Concessions need to be made if you're too inflexible or maybe too weak to get in the right position. Just remember, this is never, ever an excuse not to work the area. In fact, the opposite is true. You need to work the area, but you need to work smarter. The implication isn't that you should give up if your genetic makeup includes long legs or maybe suboptimal levers. Instead, understand that there is no one size fits all when it comes to the gym. The right way is the way that you feel comfortable with and allows you to minimize the effort and energy you're using in moving the weight the way it's supposed to go.
There are a few simple modifications to squats, bench press, and curls that can help kickstart your progress in the right direction. Squats. If you have long legs and a tough time keeping your torso up or issues with ankle mobility, try widening your foot placement. It reduces how far your thighs need to travel, so you won't need to bend forward as much. It changes some of the leg bend to a different plane. If you still have an issue after wide stance squats, try low bar squatting. This is when you position the barbell just above your shoulder blades. Provided your shoulder blades are flexible enough, the bar position helps reduce the moment around your hip joint and helps recruit more muscles in your behind. If you suffer from knee pain, avoid high bar narrow stance squats as these place greater stress around the knee. Bench press. To decrease the drop below the chest, put a rolled up towel under your back so your chest sits higher and your arm does not drop below 90 degrees, the rad power zone. Try decline press if you have shoulder issues or have longer arms. Bicep curls. If you have longer arms or elbow issues, try curling hands in towards the body at the apex of the motion to reduce the moment length. Remember, keep the core squeezed tight and the bottom, the center of gravity, under you. If you suffer from elbow pain, avoid easy curl bars and try straight bar.
Thanks for watching. While the explanations I've given might be a little rudimentary, I hope this shows you how physics can affect your form in the gym.